Today's review, we're going to be going over limiting and excess reactants, which is going to be using some of the stoichiometry skills that we learned in the last review video. So here we're trying to determine what is left over after a reaction occurs. So for this, you can kind of think of cooking. So if you want to make a grilled cheese, you look in your cupboard, you have 11 slices of bread and 10 slices of cheese. How many grilled cheese sandwiches can you make if one sandwich requires 2 slices of bread and 1 slice of cheese? So here your chemical equation is again the recipe. The numbers or coefficients in front of your recipe would be equal to 2 and 1 for bread and cheese respectively. So you could pretty easily do this math since you have the total number of ingredients and the recipe, which is in the same unit as ingredients, which in this case would be slices. So if you have 11 slices of bread, you could make 11 divided by 2 because every sandwich requires 2 slices of bread. So you could make 5.5 sandwiches. With 10 slices of cheese, since you only are required to have 1 slice of cheese per sandwich, you can make up to 10 sandwiches. Since 5.5 is less than 10, you can only make 5.5 sandwiches. So in this instance, if we were thinking of limiting and excess reactants, the bread is your limiting reactant. It determines how much product or sandwiches you can get once you finish your recipe. The cheese is an excess reactant or excess reagent, meaning that you have some of it left over once the reaction has occurred, once you've finished baking all those sandwiches. So limiting reactant determines how much you get in the end. You can't make more sandwiches because you have no bread. The excess reactant is how many reactant or reactants that you have left over. So with chemical reactions, it can be slightly more complicated because the amounts that we are given often aren't equal to the unit that is given in the chemical equation, which is typically number of molecules, number of atoms, or number of moles of atoms or molecules. And that's because when scientists are measuring out reactants, typically they're using a scale and they're getting that amount in grams. Now they might have estimated the amount of grams using molar mass, so they might be estimating a number of moles of reactant or product, but typically in these questions you are given a number in grams. So let's say that I give you the same problem, making a grilled cheese sandwich, but this time I'm not giving you how many slices you have, I'm giving you the masses of bread and masses of cheese that you have. So let's say you have 5 grams of bread and 5.32 grams of cheese. And again, if a sandwich is made of 2 slices of bread, 1 slice of cheese, what's your limiting reactant? Now you can't really just look at what you're given and solve the problem. Just because you have more grams of cheese does not mean that bread is the limiting reactant. It's kind of like if you think a pound of feather versus a pound of rocks. A pound of feather is going to have more individual feathers than a pound of rocks has individual rocks. So since things are different weights, we can't just determine how much sandwich we can make. So we need more info. How many grams does 1 slice of bread or 1 slice of cheese weigh? So here we're basically trying to convert how many from grams to how many slices that we have. So you can think of this like finding the molar mass of an element or compound using the periodic table. So let's say that 1 slice of bread weighs half a gram and 1 slice of cheese weighs 1.33 grams. Now I'm going to figure out, okay, based on 5 grams of bread, how many slices of bread do I have with this conversion factor? So I'm going to take my 5 grams and I'm going to multiply it by 1 slice over 0.5 grams. So this is exactly like a molar mass conversion, except for this is like a slicer mass conversion. And if you're ever thinking, well, do I multiply by molar mass or do I divide by molar mass? I always say like when in doubt, cancel out. So the goal here is to cancel our grams unit and end up with slices. So when I write this out, basically I want my grams units, those numbers, to be on opposite sides of the fraction line. When things are on opposite sides of the fraction line, they're going to cancel out. So here our grams are going to cancel out and we're going to end up with slices. I also, like, overall, I don't just want to know the number of slices of bread I have. I want to know how many sandwiches I make to determine my limiting reactant. So I'm also going to say, okay, one sandwich requires 2 slices of bread. So again, I want to cancel my slice unit to get sandwiches. Slice is going to go on bottom. So I have 1 sandwich per 2 slices. So if I do this math, I multiply 5 by 1, divide by 0.5, multiply by 1, and divide by 2. So here I find out that I can make 5 sandwiches with these 5 grams of bread. I'm going to do the same thing with cheese. Here I have 1.33 grams of cheese. I'm going to divide by the molar mass of cheese, I have 5.32. The molar mass is 1 slice weighs 1.33 grams. And then again, I'm going to say, well, how many sandwiches do I get per number of slices? So since this is a 1-to-1 ratio, we have 1 sandwich per 1 slice, and that determines that I have 4 sandwiches. So with the amount of bread I have, I can make 5 sandwiches. With the amount of cheese I have, I can make 4 sandwiches. So cheese is the limiting reactant, the lower number. So here's an example that actually uses some chemistry. So we have a 2-gram sample of ammonia. We're mixing it with 4-gram sample of oxygen to produce nitrogen monoxide and water. What is the limiting reactant and how much excess reactant remains after the reaction has stopped? So our first step here is going to be to find the balanced chemical equation, which I have done here. So I start with a skeletal equation saying I'm reacting ammonia and oxygen gas to get nitrogen monoxide and water. Remember, oxygen gas is a diatomic element, that's why it's O2. To balance my chemical equation, I have coefficients in front of everything. So a 4 in front of ammonia, a 5 in front of oxygen, 4 in front of nitrogen monoxide, and 6 in front of water. So if you want to practice balancing chemical equations, you can pause this video and kind of go through that and double check your answer. So that's my first step. Where did it go? Okay, there we go. Next, I want to convert from grams to moles because my chemical equation, which is basically my recipe, has a unit of moles. I'm given a unit of grams. So we can't compare grams and moles because, again, things weigh different. So I'm going to convert my reactants, their grams, to moles. So here I start with 2 grams of ammonia. To go from grams to moles, I'm going to end up dividing by molar mass. So again, when in doubt, cancel out. Adding up the molar mass of 1 nitrogen and 3 hydrogen, I get about 17 grams per mole as the molar mass. But do I want grams in the numerator part of the fraction or the denominator? Since I want to go from grams to moles, I want to cancel out grams, so I'm going to put those grams in the denominator. So in 1 mole of NH3, I have 17.034 grams of NH3. That tells me that I have 0.117 moles of ammonia. I'm going to do the same thing with the amount of oxygen I'm given. So I'm starting with 4 grams of oxygen, O2. Going to multiply them by the molar mass, which is 1 mole over 32 grams. So 1 oxygen weighs 16 grams, 2 are going to be 32. And that tells me that I have 0.125 moles of oxygen. Moving on, for the next step, I'm going to use Stoich to determine the amount of product produced based on the number of moles of reactants that I had. So first, starting with ammonia, I had 0.11 moles of ammonia. I'm going to use the molar ratio, or stoichiometry, to figure out how much of one of these products I'm going to get. As long as you're consistent, it doesn't matter which one you use in this case since we have 2 products. So I'm just going to use nitrogen monoxide just because it's first. So I'm going to use the molar ratio. There's 4 moles of NO produced for every 4 moles of NH3 used. So that tells me that I would produce 0.117 moles of nitrogen monoxide. Then I'm going to do the same thing with the other reactant. I had 0.125 moles of O2. I'm going to use the molar ratio between nitrogen monoxide and oxygen this time. So there are 4 moles of NO produced for every 5 moles of O2 produced. Okay, I need to be consistent about which product I am comparing. Again, because consistency is key. If I compared nitrogen monoxide to water, that wouldn't really make sense because they're not a 1-to-1 molar ratio. So when I do this math, I find out that I produce 0.1 moles of nitrogen monoxide. Based on this, 0.1 is less than 0.117, so oxygen is my limiting reactant. That's the first part of the question, what's the limiting reactant? I also have to answer how much excess reactant remains after the reaction has stopped. So how much do I have left over of ammonia? So from here, I'm again going to use stoichiometry, this time comparing the amount of ammonia that would be consumed based on the amount of oxygen used. So since oxygen is my limiting reactant, I know I'm using all of it, 0.125 moles of O2. I'm going to use the molar ratio between ammonia and oxygen. So there are 4 moles of ammonia used for every 5 moles of oxygen used based on my balanced chemical equation. Since they give me grams, I'm going to report in grams. So I need to find how much grams of ammonia was used so I could subtract from the original sample size. So to go from moles to grams, I'm again using molar mass. And again, I have to ask myself, what do I want to cancel out? This time, I want to cancel out the moles of NH3. So I'm going to have grams in my numerator and moles in my denominator. So this time I'm using 17.034 grams over 1 mole. So here, if I take 0.125 times 4, divide by 5, times 17.034, divide by 1, I find out that I would need to use 1.703 grams of ammonia. Now I'm going to subtract 1.703 from 2 grams, and I find out that I have remaining 0.927 grams of ammonia. Okay, so that is an introduction or review rather of limiting and excess reactants and stoichiometry, how you would solve these problems. With your limiting reactant, you're always going to use that total amount, okay? So again, relating back to the slices of bread and grilled cheese, when I had 11 slices of bread, I still included that 0.5. So I could only make 5 complete sandwiches from 10 slices of bread, but I could make half a sandwich with 1 slice. So you are always using that complete amount for your limiting reactant. All right, let me know if you have any questions.